Okay, let's look at a few more of the limits problems that were on that sort of early part of the year diagnostic assessment. So we had the function x plus 3 to the 2017, and here we see a graph of it. And basically what it looks like is it looks like it just is vertical, and it is almost, but not quite. So we said what happens as x approaches negative 4? And what we can see here is that as x hits negative 4, the value of the function jumps to negative 1. And that makes sense because if we plug in negative 4 for x, we get negative 1 to the 2017. And basically, negative 1 to any power, any odd power is going to be negative 1. Any even power is going to be positive 1. And so what we see here is that when this jumps to negative 2, we get a value of positive 1, and then it jumps up so quickly because of the size of this exponent that it looks like it's vertical. So as soon as x gets to, let's say, negative 1.99, we're already up, these huge numbers, and you can see as we get closer to 0, we're now up at 10 to the 209th power. But the main idea here is that this was one that could be evaluated by plugging in a value for x. And that value, as we said here, was negative 4, which gave us negative 1, which just evaluates to negative 1 plus 3, or no, I'm sorry, negative 4 plus 3 gives us negative 1 to the 2017th, which is a value of negative 1. Okay, this next function, we had x squared minus 5x plus 6 over x squared plus 2x minus 8. So the important thing here is that both of these are factorable. And here we can see the factorization. We have x minus 3 times x minus 2 over x minus 2 times x plus 4. So there are a couple key positions here. The first one is what happens when x approaches negative 4. And what we can see is that at that point, our function, we have this branch, which is heading to, as it approaches negative 4 from the positive side, is approaching negative infinity. The branch up here is approaching positive infinity as x approaches negative 4 from the negative side. And if we look at the limits here, we can see that as we move this closer and closer, these values are just going to start to diverge even more. And it's not going to go that high. But if we kept going, these values would get closer and closer to the left-hand limit would approach positive infinity. The right-hand limit would approach negative infinity, which means there is no limit for this function at x is equal to negative 4. On the other hand, what happens as x approaches positive 2? Let's see what happens there. So notice also, by the way, that this function is not defined at x is equal to negative 4. Okay, so as x approaches positive 2, once again we can see that it's not defined, and that would be because we'd end up dividing by 0. But instead of looking like we have these different branches, what we really have here is just a hole in the function. And so it appears graphically to be continuous, but in fact there is a hole here. The limits, as we approach from the left and from the right, are both approaching the same value here, and that value is about negative 0.17. And the reason for that is that when as soon as x is equal to 2, the function's not defined, but when x is either a little bit above or a little bit below 2, then these two factors are going to cancel out. So x minus 2 divided by x minus 2 will cancel out, leaving us with x minus 3 over x plus 4. So what happens is we evaluate this function by plugging in x is equal to 2 to the x minus 3 over x plus 4, which gives us negative 1 over 6, which is where we get our negative point, actually 16666. So here we do have a limit because the left-hand and the right-hand limits converge on this negative 1,6. So the limit of this function as x approaches 2 is negative 1/6, even though the function is not defined at x x is equal to 2. Notice also that we have vertical and horizontal asymptote here, and what that means is that as x approaches in positive infinity, f of x will be approaching 1 from below. As x approaches negative infinity, the value of the function f of x will be approaching positive 1, but from above. Okay. Now we have this function, which is 3x cubed plus 2x minus 5 over negative 4x plus 1. And we can see here that we have a vertical asymptote, and that occurs where x is equal to positive 0.25, which is what is the value of x that will make the denominator here equal to 0. So if we position our at 0.25 and look at our limits, we can see that our left-hand limit is approaching, I mean, you can't tell yet, but it's approaching negative infinity. Our right-hand limit is approaching positive infinity because the function veers in opposite directions on either side of this line, this vertical line at x equals 0.25. So the function has no limit at f of x is equal to negative, at positive 0.25. And again, that's because the left-hand limit and the right-hand limit diverge.